Hello and welcome all of you in DevIncept. Today's task is to make a project on iris flower detection. Here we use FLASK for ML model creation and also we will deploy in a Heroku. So let's start. This application is a FLASK-based iris flower prediction machine learning project. It predicts the species of a flower by taking some information like length of sepal, width of sepal, length of petal, and width of petal. All are in centimeter. So let's take a quick overview. What is the structure of the files that are used in this project? First is template. Here the HTML files are kept in this folder. Let me show you. Here you can see after.html and home.html. These are two files that are stored in template file and another static file. Static files such as image or other things are stored here. So you can see that there are 4 images that are stored in this file. And after that, iris.csv, it is a data set that is converted into CSV, where in this file whole the data of this iris flower is stored, by which we will use this file and make our prediction. Download dataset from clicking here. Okay, next is app.py. This is a Python file that contains the code of our application. The FLASK server is started here. You can see that this is a file that contains all the things. Later I will explain one by one. Firstly, let's take overview of structure. Now this is iris.pickle file. This is a pickle file which has been saved as a model. When we will detect our prediction, then this file will be created here by iris.py. This is the actual file where our model is created to predict the iris flower. What are the requirements to saved into a text file for Heroku deployment? There are some requirements also that are definitely used to deploy these files into a Heroku. First is FLASK, Unicorn, it's dangerous, you can see that NumPy, sklearn, pandas, all are given. So let's take a line by line explanation of model, how we have created the model. So the model is saved using the pickle library after it has been built. Then FLASK is used for the web browser. Okay, the SVM model is given here. You can see that. Firstly, we have to import the pandas library, import pandas as PD, then read the data set that is stored in iris.csv file and drop the first column, that is ID column. Next, you know that ML model usually work on integer type data. So for conversion of this CSV file into integer, we used sklearn.processing import label encoder. This label encoder will convert that into the integer file. Now let's splitting the columns into 4 variables. For that, from sklearn model selection, import train test split method. Here are the 4 variables: xtrain, xtest, ytrain and ytest. Here we splitted all the columns. By here you can see that df.drop column species, df species. We have splitted the columns and saved in this variable. Now after splitting into a 70-30 ratio, now importing svc function from scalability.cvm. Here you can see that. Now training our data set, we have used here linear method to train our data set. So here dot fit, first argument will be xtrain and second argument will be yTrain. Now, to importing pickle module to save our data set. For that, import pickle and pickle.dump, and first argument will be this variable where we have stored that, and next this is the file that is created after running this whole model. This file will be created, iris.pickle file. Here our trained dataset is stored. Now, what does deploying a machine learning model entails? Model deployment is the process of integrating a machine learning model into an existing production environment where it can take in an input. What it means, like we have created our model and now giving in that model inputs to get the result that our prediction is right or wrong. For this, we give an input as a training data. Now, point to consider before deploying the model. There are 2 points that we have to consider before deploying the model. That are number 1, portability. This refers to your software availability. It means you can move from one machine to other system. The portable model is one that has a short response time and it can be rewrite with little effort. So next is scalability, that maximum size of input that our model can handle. A scalable model does not need to redesign in order to maintain the performance. So here are 2 points that we have to consider before deploying the model. Now, factor to consider when choosing a deployment method. So here we have used a linear method. So for why we have used the linear method? There are some factor to consider when choosing a deployment method. Number 1, how often will prediction be made and how urgently will the result will required. And next, if the prediction should be made one at a time or in batches, it means prediction should be made once at a time or in a number of atoms. So now the model's latency requirement, one's computing power capability, and the desired SLA are all factors to be considered. Last point is model operational implication and cost to deploy and maintain. What will be the cost to deploy and maintain our model? Now, why we have used FLASK? So, what is FLASK? A FLASK is a Python-based web application framework. FLASK provides us with a number of options for deploying web application as well as the tools and library we will need to get started. Actually, what are the features of Flask? Why we have to use Flask? A micro framework with a lots of features. A quick template. There are very quick templates available there. WSGI features that are very strong. A lot of documentation is available in internet. So by this, you can take an help from internet by reading the documentation part of Flask. Now that you have built a variety of predictive model, it's time to learn how to use in a real time. So for that, we have to import Flask render template and request from Flask. Now importing pickle module, importing numpy as np. Now loading the iris.pickle, that is where the model is generated. Now there are 2 functions. Number 1 functions defman. Here you will return the home page. Let me show you how the home.html will look like. It will look like this. Okay, next function is to store the input data, and after storing the data, make an array of that and give that value to the model which we have made it earlier, and returning the after.html file and returning the result of that model. You can see that after.html file will be give the result like this. This is the after.html file which will be render after clicking on predict button. And here app.run debug is equals to true. It means we need not to rerun the program after giving an inputs. It automatically rerun. It means we don't need to reload the program. It will reload automatically. After clicking on this back button, we will come to our home page. Okay. Now let's talk about what is Heroku. Actually, after this making of file, we will upload the whole program in Heroku. We will deploy there. So what is Heroku? Heroku is a cloud-based platform as a service that allows deployers to create, run, and maintain applications entirely in the cloud. In cloud, we will deploy our program. We need not to worry about the underlying hardware or networking. Okay, Heroku is also known as polyglot platform because it has a features that allow deployers to build, run, and scale application in most language in a similar way. It enables software deployers to create and run complex web applications. So what are the actual features of Heroku? Why we use Heroku? An easy to use tool. There is no requirement for infrastructure. A fantastic command line interface present there. Extensive add-on toolkit is present there. Deploying from a variety of sources. So here you can see that this will be the home page and this will be the result which we will get after giving all inputs and clicking on predict. So let's come our VS Code to. Here you can see there are two folders. Static folder store the images and template folder store after.html file and home.html file. So first we have to run is.py. This where we have created our model. So let's run this and you can see here the iris.pickle file will be generated. Yeah, that will take some time to run that. Yeah, you can see there iris.pickle file is generated here. Now we have to run our main file that is on app.py. So let's run this app.py. Uh, Here you can see there a link will become restarting with the stack. Wait. Yeah, here you can see this link has came. Control plus click we have to do. Now you can see it is a home page. So let's give an input 1.526 and 1. Let's predict. You can see the iris.virginica prediction is done. So let's deploy our whole project in Heroku. Firstly, I have to upload all files into GitHub. Then we have to link my GitHub with Heroku. For that, we have to make two files. One is proc file and requirement.txt to upload this into a Heroku. What is proc file? It will give an web.unicorn bend app.py. It is a flow how this whole deployment will be done. It is given here. And now requirement.txt. What are the requirement things like FLASK, unicorn? These are requirements that we have to do while deploying in Heroku. So let's upload all this file into my GitHub. Okay, it will take. Here you can see all the file is uploaded here. Static, template, iris, CSV, proc file and requirement.txt. That is very required file to upload in Heroku. So let's deploy this in Heroku and connect our GitHub repository in that. So for that, click on create new app. Let's make a new app name Iris 432. Let's see, it is available. Yeah, create app. Now we have to connect our GitHub to this. So click on this, connect to GitHub. Search the repository name, that is FLO. Let's search it. Okay, connect. Click on here. This is a live demonstration on how to deploy our app in Heroku. Click on this. Okay, deploy branch. Now it will take some time while uploading all the files into a cloud. Here you can see all files are uploaded. Your app was successfully deployed. Now click on view. Here give an input. This our home page appears now 2.5, 4.0 and 1.3. Click on predict. Versa color is appearing. Here you can, by clicking here, you can go to our main page back. Okay, now giving another input. 3.3, petal length 1.4, petal width 0.2, and now predict. Now Setosa. Okay, all the prediction have been made. So that's it. You have uploaded the GitHub file into Heroku and then deploy the app, and here it is our result. So thank you very much. Goodbye.